All right, so in this video, what we're going to do is we're going to kind of go over the infinite switch. We're going to kind of discuss how the operations, how the contacts work, the general theory of operation, and we're even going to kind of look at some diagrams so that way you can kind of get a full understanding of what we're dealing with. Now, bear in mind, there's plenty of other videos online where people go over it and they say it in much clearer terms than I generally do. A lot of times I tend to rant and rave, which works for some people, other people it just drones on. So if you're looking for a quick, concise video on infinite switch operations, you probably are better off going somewhere else. But if you like these videos where we're going to try to break things apart, take a look inside and really understand how they work, then yeah, I'd say you might be in the right place. Might not be. I might not get the right terms here and there, might fudge some stuff up, but hey, we're all here to learn, we're here to have fun. So on this infinite switch, it's going to be a WB24T10025. It's pretty common one, pretty standard. This one is for a single element burner. And on the back, it was kind of tough to see in the light. So I drew in the colors. I just used a red marker and then washed it away. Excuse me. So that way we can kind of see what we're looking at. Now, when it comes to an infinite switch, you're going to be dealing with 240 volts AC. Now, when we look at this one, and this isn't the best diagram that I found, but it's going to serve the purposes for this training video. So basically, when you're dealing with an infinite switch, you're going to be dealing with 240 volts. So what we have here on this diagram, let's scroll up. We got L1 coming in down to this way to our L1 terminal, obviously. And then we have L2 right there, which is going to come in and come over to the L2. Now, if you've been going through the training videos, you understand, or if you know basics about, electricity and bake elements on an electric oven, you know that the surface elements get 240 volts. And what is the 240 volts? How do we get that 240 volts? Now, if in the back of your mind you're saying, well, that's simple, you're getting two 120 volt legs of voltage that are out of phase with one another, then you're right. And pretty much we want to know that just to understand how the circuits work. We get L1 coming in this way, and when we're looking at our resistive load, the surface element in this instance, L1's coming in on this side, boom, and then L1 is coming in over here. So we have a resistive load between those two 120 volt lines, that are out of phase with one another. If we put them together without this resistive load in there, without resistance between the two, we would get a pretty big electrical short, which we don't want. So to prevent that from happening, and as a safety mechanism and overall just to make sure we don't have a failure in case the element grounds out, we can see that between line 2 and here, you got two switches. We're not going to worry about that right now. We got this switch, which is going to be inside of the infinite switch. And when you're looking at the diagram, one of the feedback things I'd gotten, somebody said I didn't really go over what the different dots and whatnot means. And that's a valid point. I didn't even think to put that in there. When you're looking at a wiring diagram and you see a little black dot kind of like that, typically what that means is the wires are spliced together or they branch off. If they just go right over without a little dot, kind of like that, you'll get a loop-de-loop sometimes, a little jump over. That means they're not connected, two different lines. But when you have the little dot, that's where they join. So you can kind of see it here. Neutral comes to the oven light, and then it also comes into the neutral on the board. We're not really focused on that. We're more focused on this. So when we're looking at symbols and diagrams on the wiring sheet that we're looking at, L2, this is going to come into a terminal connection on our infinite switch. Let me get that down the light so we can see it right there, L2. So we know L2 comes into right there. And if we look at this diagram, if we look at this, from L2, from the wall pretty much, or the terminal block, it's a straight shot in. So when we have our oven and we come to the infinite switch, at L2 right there, if we check that to chassis ground or any exposed metal, we're going to get 120 volts. There's no switches or anything that should be doing that. So if you have, let's just say, the left front element and it's not working, first thing you'd want to do, verify we're getting proper voltage to it. So we just traced out where L2 comes into it. Comes in right there. And then same thing with L1. If we're looking at our diagram, comes directly in from the terminal block. It doesn't really say that right there, but we're going to assume that comes in from the terminal block. Comes straight down and boom, right into the L1 terminal. And if we look on the back here, let's see. L1 right there at the top. So this one and this one, if you were to check AC voltage across these two, you'd get 240 volts. And that would be regardless of what position this is in, whether it's on or off. We should always have 240 volts AC and 122 ground on each one of those present at all times. If you don't have that there on L1 and L2 coming in, then you've got a problem either at the terminal block or the wiring between this and the terminal block. So a lot of times when it comes down to voltage, it's just seeing where it is, where it isn't. You got to understand where it's supposed to be and where it isn't supposed to be and in what state. Once you really start to understand that, you're able to diagnose problems without just replacing parts, hoping it's going to do the trick. And that's really the purpose of this training. So you get a full understanding of how these things work to the point where you as a technician, when you're going into a customer's house and they're paying you money, you're doing the job right and you're getting it done properly. So with that being said, let's go ahead and take a look at it a little bit further. Now, let's just start with L1. What happens when L1 comes in? We know it comes into the L1 terminal right there. We just found that. So inside of the switch, between these 2 points in there, we have this little switch right there. So, in theory, in the open state, when the unit is completely off, this is going to be entirely open. Now, let's look at what happens if, nothing here is saying that this is open. In fact, if you look close enough, it almost looks like it's touching the P terminal. What would happen if either one of the two of these contacts were closed? Well, if we did, we would have 120 volts now coming to P, which if we look on here, it's kind of marked off, but P is going to be right there. Generally, P is going to be for your pilot light. Pretty simple to remember, P for pilot. So, and that just means your surface indicator light. And sorry, I should probably clarify, pilot light, sometimes on the older ones where you got the little flame that's always there, two different things, but P, it's going to be your surface indicator light. So if the infinite switch were in the off position, no heat or anything, this would be, if we thought this was closed based on this, then our surface indicator light would be on because it's connected directly to neutral. So obviously, when we look at the diagram, we can tell that should be open and this should be open. We shouldn't be getting any of that 120 volts. It should stop right there inside the infinite switch. So now what we can do to test that out real quick is we can grab our meter and, dang it, bear with me. I started filming this sideways and I have this thing here to hold it so I can actually do some tests. Well, we're gonna do it this way. Hopefully the output doesn't look too ridiculous based on how you're looking at it, but I think we can get the gist of it. So, anyways, what we'll do is we're gonna come over here, we're gonna take our meter and we're gonna set it to resistance or ohms. I always prefer ohms over resistance, or not, sorry, those do the same things. I prefer ohms over continuity check because when you do a continuity check, you're typically just getting a beep. Now, once you start understanding when switches are in the closed state, they should have as little resistance as possible. You're typically looking for half an ohm or less. And the reason why is when you have resistance in a circuit, voltage is dropped across that resistance. So if we had a switch, let's just say here, line 1 to H1, which we'll dive into in a minute, if we had a whole bunch of resistance there, we'd be dropping voltage across that rather than the heating element. And we don't really want that. So for me, I always like using resistance rather than just continuity. But for this testing, we're just going to do continuity because I can't really have both of these in the shot. No, can't really have both of them in the shot. So for this purpose, we'll get the noise. Now, one thing too, if you're new with using meters and whatnot, you always want to kind of check your meters to make sure they're working first. There's been plenty of times where the little connector at the bottom, it's kind of like that. At face value, you're looking at an angle, it looks fine. but you're not really getting good contact. Always want to make sure those are in good. And the best way you can test it is just putting your leads together. And then the same thing kind of holds true if we were to do just resistance. See if I can get all this in here. Put your leads together. Look at that, 0.1. So very close to 0 ohms, which is what we want to see. So we know our meter is working. We're going to put it back to our continuity so we can get the beeps. And remember, one more time before we do this, we're going to be checking L1 to P. Okay, let me put this back here. L1 to P. So right now it should be in the open state. So, or when I say open state, in the off state. So nothing should be happening. And let's check L1. See if we can do this right. L1 to P. We've got nothing. No beeps or anything. So that circuit is open. Now, if we take a look at what else L1 goes to, it goes to H1, which when we trace it out, H1 goes to one side of our surface element. So let's do this. L1 to H1, just so you can see. H1's right there, L1's right there. So in this current state, where it's off, would not want to see any resistance or any continuity. And we've got nothing. And just to confirm, got that there. Seems like the camera's focusing on the wrong thing. There we go. So basically in the open state, that's what we're seeing. Now let's take it a step further and let's just assume the customer is pushing it in and they're turning it on. They want to cook up some pasta or something. So what happens now? Let's kind of circle back around to refresh ourselves. L1, when it's closed, we're going to expect it to close voltage to the pilot light, or surface light, sorry. So our surface indicator light should be on, so this circuit should be closed. And we also are wanting to get 120 to this side of the surface element. So L1 to P and L1 to H1 should now have resistance. Make sure we get this set so the phone doesn't fall. Stop! Yeah. Really need to get a phone holder or whatever, but whatever, one day. So L1, if we check now from here to P, let's try. Okay, don't think I was making good contact. Whoops. So H1 to L1, you can hear the beeping, and let me see if I can get the meter in here so you can just kind of see. Now let's stop and let's kind of go back and we'll just do resistance. See if I can jam these in here. So let's see what kind of resistance we got. Remember, we're looking for very low resistance, and as soon as it focuses in, you can see we're getting 0.1 ohms, which is perfect. If we were getting 7 or 8 ohms, that'd be concerning. We'd be getting a lot of heat generation inside of that. Now let's see if I can try it again. I don't know if I was making good contact or what have you. Come on now. Yeah, just a second. Okay. So now we have it on H1 to P. Honestly, I don't think I'm making good contact on that. But we can see it's a closed circuit now, whereas before it was not. And then likewise, when we come down to the L2 side, L2 just goes to H2. And remember, when it comes down to infinite switches, they're very simple. They're just simply opening and closing L1 and L2 to the circuits. And then you've also got the one that goes to the surface indicator light. You know, I've seen a lot of times where you unwire it and then you're not entirely sure how to rewire it. You know, A, take pictures before you take things apart. That way you know. But B, if you do that, just understanding the basic concepts of electricity. You're getting 120 in from this side, 120 in from that side. We need a resistive load between line 1 and line 2 or else it's going to short. Then it's as simple as figuring out which wires can go where. Nonetheless, we're going to circle back around. This will probably end up being a long video because I'm going to pause it and then rip this thing apart and we can look inside. And we're going to go over a little bit more theory as well. But last test for now, come on. L2 to H2 right up here. So if we check and it's not on continuity, let's do that so we can get the beeps. There we go. And look at that. We're getting beeps. So this is a good working infinite switch for all intents and purposes, and that's about the thick of it. Now, kind of diving into theory, now that we understand how the internal contacts open and close when we, there we go, when we, turn the knob on and off, and understanding how the wiring works when it comes to that, pretty simple, pretty straightforward. It's one of those things, if you're not sure how it works and then you learn how it works, you're like, oh, wow, very simple. So anyways, the other thing, what we're going to talk about is how these regulate heat. Now, notice this little crossbar here kind of comes over here and it pushes down. So, and then inside of here, let me see if I can, we'll just use this as a pointer. Inside here, if it will focus, notice how you've got this one little strip, and then underneath it there's another piece of metal. Let me see if I can do this on here. Basically what that is, before I do that, that is a bimetal strip. So what we've got are two dissimilar pieces of metal that have different heating expansion rates. So each metal pretty much expands at a different temperature. So when we engage the switch, click it on, current is actually flowing through that strip and it's heating it up. So it pretty much, the current flows through, it heats it up and it causes it to bend. When it bends away from a contact and it opens one of our legs of voltage. Now, without me really jacking around with it too much, I don't know if I can, to kind of show you how that opens and closes it. Basically, in there, and maybe it'll clarify a little more once we rip it apart, but current flows through it, and that piece of metal in there bends away, and it opens one of these contacts, most likely L2. When it starts to cool down, because no current's flowing through it, it goes back down, and it resupplies one leg of voltage, the other leg of voltage to the heating element. Now, the cool thing about that is, inside here, when you are twisting this, you got a lot of power to it, and having the knob definitely makes it easier. But when we're twisting this, I don't know if we can get a good angle. Let's see. When we're twisting this, it adjusts the pressure on that bimetal. Let's see. Yeah, there you go. You can kind of see it. Whoops, moving there. So when we want it on higher heat, let's see. Yeah, you can see it kind of moving up. When we have it on higher heat, we're putting more pressure. Hi, what you doing? We have more pressure on that bimetal strip, so it's going to require more heat to open up, and it's going to stay on longer. So I think we looks like, what, 18 minutes spent on that. Definitely talked a little bit longer than I meant to, but hey, nonetheless, we're all having fun, and we're really just trying to take some time with this to fully understand it. If you blast through it, sometimes you just don't retain what you're looking for. So what I'm going to do, because I got a whole bunch of sirens in the background, living in a new place now, and I think there's a fire department just down the road. We're going to go ahead and stop the video. I'm going to kind of pull this apart, and we're going to take a look at it on the inside. All right, so we were able to pop this loose. And basically, just a couple little tabs there and there. And again, I mean, guys, 9 times out of 10, or I'd say all the times, if you have this connect and you're not getting it working, you check voltage in and you check voltage out. We're getting voltage in, no voltage out when it's on the on. You know it's a bad infinite switch and it needs to be replaced. There's no real need to rip it apart to figure out the main failure case. But me being me, I like to see the inside of things. I like to know how they work. That way I just get a better understanding. And then, every once in a while you get a customer that's curious, and when you can tell them exactly what's going on inside, then you definitely come off as more professional rather than just telling them, hey, I'm going to replace this part and hope to God it works. So with that being said, let's see what we can do here. Whoops. All right. So we kind of pulled that out. I didn't mean to. Pop that off. And we're going to set that there. So, yeah, we got some grease down there. So basically, let me wipe my hands off here. All right. So inside, you can see we kind of got some cool stuff going on. Don't know what the numbers mean off the top of my head. DHAB. Anyways, point aside. So when the user, let's just pull that off and just take a minute and geek out and see what we're looking at here. So I wonder if those will fall out. No. So we saw it on this side. It was kind of tough to see. And then when we pull this out, look at that. Let's see. That's a better angle. Okay, maybe a little bit of a better angle. Let me grab this tool. Okay, so we have our bimetal strip right here. And then if we, let me get a little pressure on it. There we go. So you can kind of see when we're pushing that down, that bimetal strip, it makes contact. So, and then what we can also see, and I'm sorry if it takes so long to adjust the filter. I can't, not filter, but the words aren't coming to me today. Whatever. Anyways, so on this side, that's our bimetal strip. Current goes through it, it heats it up, and just this strip alone bends. Now, what you can see on this side is where L2 comes up. Let's actually check. Let's check and see, because it comes straight through there up to this piece. So if we go right over here, yeah, look at that. So L2 connects to this piece, which connects to that piece. So when L2 closes that contact, we have L2 coming straight through here, and yep, straight through there and through that metal. Okay, so what it's doing, yeah, L2, when it closes the contact right there like that, when this plunger is engaged and moves, and you can kind of see on the back side, got a little bit of a ridge there. See that? So what happens is that ridge pushes that piece of metal down, either applies more pressure. Come on now, focus, there we go. More pressure to that bimetal strip or less pressure. More pressure, higher setting, low pressure, lower setting. So current's flowing through bimetal. Remember, one piece of metal and a dissimilar piece of metal cause it to kind of bend. Same thing up here. And you can see that's where the contact is made. So pretty nifty, pretty simple, which is what I like about them. Now, the other thing to note too is a common failure you're going to see with these. Either the pilot light staying on all the time, or we're not getting that. Think about it when you take two wires, put them together without a load in between. You get a little short or a little arc, a little spark. That's going to be happening quite a bit inside of here. When that touches, releases, touches, releases. So over time, you're going to get buildup on those contacts, which is going to cause it to not fully make contact and pass voltage through. So that's a failure state there. Now, being curious, let's take a look at our L1 side. So if we come back over here, L1 comes into this terminal. So if we look there, it kind of terminates there. You got that little plastic divider to make sure L1 and L2 don't touch one another. And then let's see here. L1 comes up. So when it's in this off stage, it's not making contact with that one. It's up, just like we can see here. And then what is this one down here? So it's just a little piece of copper, comes up over here to the P, so our surface indicator light. So, and again, that could fuse over time. Those two can heat up and fuse together, and then we'll constantly get that, so you'll have your pilot light on, sorry, surface indicator light on all the time. And then we can see up here at the top, let's see, yeah, just a little piece of metal there. So when our switch pushes in, it makes contact with both of those, which then sends out to H1. So that's pretty neat. And then again, just you can kind of see the ridges right there as we go around. And basically those ridges, again, if I can get this seated properly, There we go. Those ridges, just focus on the right thing. There you go. You can kind of see as we move it in one position or the other, we are opening and breaking contacts. We're changing the amount of pressure to those contacts. All right, I think we beat this one home pretty much as we're going to. So I'm gonna leave it at that. Definitely took a lot longer, could easily make it shorter and truncate it, but where's the fun in that? We're here to learn, and I like to take time with things, really get to understand them, and hope you guys do too. So thanks for taking the time. Hopefully this was useful. Unfortunately, where I live right now, I don't have an electric stove, I just have a gas stove, so I'm not really able to show you actual live voltage checks, but we kind of went over the basic theory, basic functionality, and so long as you have a decent a decent understanding of voltage potential, voltage drop, having a resistive load between, line 1 and line 2 as being that, then, all this other stuff comes with it, and you really get to kind of understand and appreciate what it is that you're seeing. All right, we'll leave it at that. Thanks.